Greetings of the day. This is Dr. R. SATHIYAPRIYA, Assistant Professor, Department of Physics, Trinity College for Women, Namakkal. The topic is Introduction to Nanotechnology. What does nano mean? It's nothing but a smaller in size, lighter in weight, and stronger in strength. Compared with macro materials or large materials, microparticles and macroparticles, nanoparticles are very small and very tiny in size, and also it is very lighter in weight, but it is too stronger in strength when comparing to the micro and macro. Nano is derived from the Greek word nanos, meaning draft, and its prefix meaning is extremely small, and its SI unit is 10 to the power of -9. Nanotechnology is broadly defined as the understanding and control of matter at dimensions of roughly 1 to 100 nanometers, where unique phenomena enable novel applications. Father of nanotechnology. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. Richard Feynman, who is none other than a father of nanotechnology. There is a plenty of room at the bottom. This is an invitation to enter a new field of physics. One fine morning, a classical talk by Richard Feynman on December 29, 1959 at Caltech, California became the silver sword for the future of nanotechnology. He asked the question to the audience, why cannot we write the total volumes of encyclopedia on the head of the pin? That is the entire 24 volumes of the encyclopedia. Is it possible? Yes, it's possible. Because nano is very tiny. For example, can you see the human hair? Yes. Just take your human hair, a single hair, and split the hair into 80,000 split, and which is equivalent to 1 nanometer wire. That's possible. Is nano a new technology? No. Nano is not really a new thing. Nano is introduced by our ancients people. This is a Damascus steel which is made of nanoparticles, and a Lycurgus cup, 4th century AD, now at the British Museum, London. So, they have used grind powders of gold and nano for coloring these metals. Ancient stained glass makers knew if they put finely ground gold or silver in the glass, they would get beautiful colors. They used nano-sized gold and silver particles. Optical properties changes with the nanoscale. Wonders of nature, wonders of nano in nature. Yes, these are the wonders in our day-to-day life, daily life. We can see these wonders in nature. Yeah, the feathers of butterflies. If you touch the butterflies, you can feel some colors of powders on your hand. It is nothing but nanoparticles. While you are seeing the lotus leaf, the water will not absorb by the leaf because there is a coating of nanoparticles on the upper layer of the lotus leaf. So many of the examples we can give for the nanos in nature. And these are the diameters, and these are the particles, examples of nanoparticles in meters. How it's comparing to the nanoparticles, how they are big. This is a 5 mm of ant, and this is a dust mite, 200 micrometer, and there is a human hair 10 to 50 micro wide, and DNA is 2 to 12 nanometer in diameter, and red blood cells are 2 to 5 micrometer wide. Two parts of nanotechnology. Nanotechnology is often divided into two parts, nanoscience and nanotechnology. where researchers learn about the chemical and physical properties of materials at the 1 to 100 nanometer scale. The materials at 1 to 100 nanometers are called nanostructures. They are the smallest thing that can be made. And what is nanotechnology? Where the researchers develop and apply materials at this scale to develop new products and methods, that is, turning nanostructures into usable tools and applications. These are the difference between nanoscience and nanotechnology. Why nanoscale is special? Because nanocrystalline materials are exponentially strong. They are hard, they are ductile at high temperature, they are wear resistance, they are erosion resistance, they are corrosion resistance, and they are chemically very active. Nanoscale size effect. Realizations of miniaturized devices and systems while providing more functionality. Attainment of high surface area to volume ratio. Manifestations of novel phenomena and properties including changes in physical properties, chemical properties, electrical properties, mechanical properties and optical properties. Surface to volume ratio. A 3 nanometer ion particles have 50% of atoms on the surface. A 10 nanometer particles have 20% on the surface, and 30 nanometer particles have only 5% on the surface. The properties changes when compared to macroscopic systems. This is due to large surface area to volume ratio, which alters the properties of materials. The applications are also changes when the properties changes. For example, opaque substance can become transparent. The material can be a copper. Stable materials can turn combustible. For example, aluminium. Insoluble material may become soluble. For example, gold. Changes on nanoscales. The majority of atoms are almost all on the inside of the object at the macro scale level, and the majority of atoms are split between the inside and the surface of the object. And changing in object size has a very small effect on the percentage of atoms on the surface of the macro scale, and the changing in object size has a big effect on the percentage of atoms on the surface at a nanoscale. The melting point does not depend on size at the macro scale. The melting point is lower for smaller particles at the nanoscale. There are different types of synthesis method used for the particle synthesis. Top-down methods and bottom-up methods. Top-down means the size reductions. The bulk material is reduced into the nanoscale level, whereas a bottom-up method is nothing but building a molecule by molecule, atom by atom from a smaller entities. Examples of top-down methods are mechanical milling or ball milling, chemical etching, thermal ablations or laser ablations, explosion processes, sputtering. An example of bottom-up methods are chemical and electrochemical precipitations, vapor depositions, atomic or molecular condensation, sol gel processes, spray pyrolysis, laser pyrolysis, aerosol processor. And there is also bioreductions also there. They use metal salts for the reductions and NADPH for the reductions, and metal nanoparticles, here NADP. These are used as plants, microorganisms, macrofungi, macroalgae and mushroom seaweeds, etc. for the bioreductions. The applications of nanoparticles include textiles, biomedicals, healthcare, food, agriculture, industrial, electronics, environment and renewable energy. These are notable applications of nanoparticles. Is nanotechnology the gateway to the future for human being on earth? It's a question mark. Thank you for listening.